I'm really pleased to have Troy Stovall join us. He is the new, CEO with and executive director for Maryland TEDCO. And for those that are unfamiliar, that's the Technology Development Corporation for Maryland. And I'll let Troy go ahead and introduce himself and TEDCO a little bit. And he'll be introducing our speaker for this session, giving a perspective from agriculture on data security. So thank you both for joining us today.
Mike, thank you. I appreciate you and appreciate your leadership for the state and what you're doing with cyber tech and CyberAg. We appreciate it. And I've gotten to know you well, obviously, with your role at TEDCO. So good morning, everyone. My name is Troy Lamel Stovall. I am the fairly new CEO and executive director for Maryland TEDCO. TEDCO is Maryland's entity, venture capital entity, where we provide early stage investments to technology-enabled companies, but we also provide wraparound services for them as well. So if you'd like to learn more about us, you can visit our website, which is tedcomd.com. So looking forward to that. But today, my role today is one I'm very excited about, because as the CEO of TEDCO, we very much are interested and think that and believe that Maryland can and should lead in the development of cyber, particularly around agriculture. And Mike and I have had a lot of conversations around this, as well as aquatech and agritech. So this is very germane, because it's an intersection of areas where, like cyber, where there's clearly a leadership role that Maryland already played, and around agriculture, which it also is a clear leader in the country. But I'm proud to introduce Aaron Ault. Aaron is the senior research engineer with Open Ag Technology Group at Purdue University, home of the Boilermakers, where he spearheads the development of several open source ag-related activities, including the Open Ag Data Alliance, an Open Ag Toolkit, and ISO Blue. He has contributed to projects across the computing spectrum over the last 15 years, which includes signal processing, data mining, visualization, embedded systems, software engineering, wireless sensor networks, and web applications. Aaron is also vice president of Ault Farms, which I think you're going to see in his background, where he works full-time, both managing daily operations and getting his hands dirty. Ault Farms is a Midwestern family farm operating with 3,200 acres. I'm going to repeat that, 3,200 acres of corn, soybeans, and wheat. And what I love is 3,000 head of beef cattle. You know, Aaron, I got to say, before I close, this is the problem with this visualization, because if we really were doing this live, you would have had to bring some food so we could have sampled some of the food from the farm. But in closing, Aaron received his BS and MS degrees in electrical and computer engineering from Purdue University, again, home of the Boilermakers. So Aaron, we're really welcome to Maryland, and welcome to working with us and talking to us today. So we look forward to hearing from you.
All right, thanks, Troy. And thanks to Mike for inviting me today. Welcome, everybody. As Troy said, my name is Aaron Ault. I've actually been to Maryland once before with Mike on a whirlwind tour. I think it was like 6 talks in 2 days or something like that. So I have very fond memories of my time out there, and I met a lot of great people out there at the time as well. So I was really excited to do this, get an opportunity to speak here as well. So my talk today, bits about food. I'm going to talk a little bit about privacy and security in agriculture, but also try to give you a little bit of an overall view of what does data in general look like in agriculture? Like, where does this, security and things come into play here? So as Troy mentioned, this is my farm right here. So I'm an active farmer. I just came in from treating some cows this morning. Actually, my cows are over here in this area, and this is where my corn and soybeans go. But I'm also a computer engineer, an active software developer, and helped to co-found the Open Ag Technology and Systems Center at Purdue. And so what the point of our center at Purdue is to try to bring some of the innovative power of open source culture to the agriculture space. We actually have several kind of deep domain experts in a lot of different areas that kind of touch data in agriculture, from stuff on the ground, sensors, machines, livestock, video monitoring of livestock, things like that. And of course, connectivity, telematics, rural broadband, communications. We do a lot of then from, kind of from the edge forward, a lot of work in the security and privacy space, clouds, APIs, we write apps, we do machine learning, and we've also got a pretty heavy presence in the supply chain under our Trellis framework. from there, the primary point I like to get across to audiences maybe that aren't as familiar with agriculture is that the main thing farmers really want from data, what they're trying to do with it, is that it should flow from wherever it starts to wherever they want it to end up without them having to touch it. That's the primary thing that they want. They want to be able to farm and essentially have all the data stuff happen the way it's supposed to happen, and they can focus on their core business. And it seems like, yeah, that makes sense. I mean, we at Purdue, we're also ag researchers, right? We do a lot of research, collect data out in the field. This turns out to be sort of what ag researchers at universities want out of data as well, right? Anybody dealing with data in ag tends to say, yeah, we want it to start at the field and have the shortest path to my MATLAB chart without me, having to drive out 2 hours to collect stuff out of something and get it into the graph. And this is actually what the machine learning community in agriculture wants as well. That they're really looking for data sets, right? Like I want to answer my question, I want to build my models, but a lot of years of time spent collecting data out in the field is kind of a pain and expensive. But it actually turns out this is what everybody wants from data. It doesn't matter where you are. This is not an ag specific problem. What everybody wants from data really could be summed up in one word: automation. That we don't want to have to think about it. We want data to get where we want it to go without a lot of work. But if you look at traditional sort of automation, the traditional stuff I'm not supposed to have to worry about in agriculture, we also call it interoperability. It looks like this. It was essentially buy all your stuff from one company and then all your stuff will work together. So if you have all green tractors, then all of the stuff you plug into the green tractors will work. You don't have to worry about it. And they would all talk about paying lip service to standards, but in reality, agriculture is still to this day, even though the standards exist, was sort of driven by the business model that made machinery companies successful, which was proprietary, siloed, inaccessible data. And that works when you're building machines. It doesn't work when you're dealing with data, because unfortunately, there's a whole lot more on my farm than just tractors. And so there's no one company that builds all the things on my farm that produce valuable data for me. And so like interoperability is sort of the name of the game in data in agriculture. Things have to work together or the market is severely limited. And so if you look at taking that traditional business model in ag of siloed proprietary stuff and you apply it to the digital domain, you get this slide that I see a lot at ag conferences, where an ag data company will stand up and they'll show this slide and their cloud's in the middle. They don't put the flames of Mordor behind it, but their cloud's in the middle. And they've got all the rest of the ag industry around the outside. And they say, essentially, once all the world's ag data flows through our cloud, then all your stuff will work and it'll be great. And you can get back to farming and you won't have to worry about interoperability and things like that. But unfortunately, the farmer sees this. Well, I should say, this guy presents it. Everybody gets excited and he sits down, and then the next guy stands up and he actually has the same slide, but his cloud's in the middle. And you think, did you see the other guy's slide? Because his said his be in the middle. Like, what does that mean? His stuff can't work if your stuff is going to work, or what? And of course, the farmer the whole time he sees this and he's just thinking, one cloud to rule them all and in the darkness bind them, right? Like if your business model is, I need to tie the mast of my farm's ship to your business in order for it to work, it's a limited market. You're asking for a pretty big leap. That we'd rather have things distributed. And of course, now the new thing is blockchain. If we all just pick the same blockchain, then all of a sudden we'll gain on interoperability and all of our problems will go away. But this problem still doesn't. So the question really is, how do you achieve the data automation you want in agriculture without the centralization that you don't? And I think the answer that the tech world has shown us is open source, right? That we need sort of open source framework level components that allow data to kind of plug in from one system to the next. And that's some of the work that we do at the Oats Center. The Open Ag Data Alliance Framework and Trellis, which are kind of two brands for the same thing. These are sort of general purpose interconnectivity protocols. And so I'll give you an example of what this looks like in agriculture. that what does automated data actually look like on the farm when you have multiple companies that you're interacting with. So, I may be a farmer that has a combine, and I'm progressive, so the combine has a telematics unit. Maybe it's got our IsoBlue unit that's open source that we make from the cloud at Purdue. And it streams data from your combine, your harvesting machine, into the cloud, and you can view it on your tablet, look at it on your computer. It makes really pretty maps. It's really neat. And then all of a sudden a new company comes along and they say, hey, if you could give us access to the data feed off of your tractor, we can predict when bearings are going to go out, or we can track when your when your oil needs changed or the hydraulic filters need changed. We can do all kinds of stuff to make sure your machines stay running at peak capacity. And you think that's great. And they say, we just need all that data that's streaming off of your combine. And so you go to the OEM's cloud and they have a little button that says export. And you're like, oh, okay. So you click export and email it over to the machine health people. And they say, all right, this will work great as long as you do that every 3 minutes. And you think I don't think there's not a lot of farmers that want to sit there and click export every 3 minutes, right? They need to be able to have a live connection back to wherever your data is actually sitting so that they can monitor it and give you alerts. And of course, the first time that a farmer starts getting data in a couple different places, they're going to want to simplify from their perspective. They're going to want to pick a cloud of choice, right? The place where all my data sits. And so all the things that produce data need to get it there, and all the things that consume data need to pull it from there. And that's kind of my master data repository. In the enterprise world, that would be SAP. But in the farm world, which is much more heterogeneous, that's going to be a huge long list. Sometimes it's Google Drive, sometimes it's just Google Sheets, spreadsheets. Like, it's all over the board as to what that actually is. But once you have that central place, it now becomes easier for new companies to give you services that don't require you to change your whole farm over to all of their products, right? You can buy field sensors from one company that sample soil moisture, and then you can feed the soil moisture sensors values to a benchmarking service that tell you how well you're doing compared to other farmers in your area, and giving you ideas of how you could improve. And those things are pulling data from university trials. It could be feeding to a recommendation service that's telling you how much nitrogen to apply, or maybe we shouldn't spray today, we should spray tomorrow, those kinds of things. And my personal favorite, just logistics management, because most of your time on the farm is spent dealing with logistics. And of course, you also have third-party service providers. We in the US tend to call these co-ops, where they'll spread some fertilizer on your ground, they'll produce data from that, they'll do soil tests, things like that. And all that is data that's relevant to your farm. But you see, as a farmer, you have this big web of interconnected services. You don't have necessarily that all the data flows through a single blockchain, right? Like, all of these things need to work together for any of them to be able to provide you value from data. And of course, in this picture, from the farmer's perspective, or from a food supply chain company's perspective, blockchain is sort of a thing off to the side. It's not the central thing. It's an extra thing that I have to push things to. And so it doesn't necessarily solve the problem of how do I get data to flow through this kind of ad hoc, strangely connected graph. And so one thing to pull out of that is that the person that made this graph was not the individual companies. It was the farmer who had the need, who was buying services from all these things. So he needed the ability to connect all of the different disparate services that maybe don't even know anything about each other to get data flowing. And so the abstractions that you need, the components of that network that have to exist, are you need API connections, period. Things have to be real time and they have to flow without me in the middle. You need microservices, right? You need things that can process on the data streams that are happening. You need storage and caching layers. You need things that act as the cloud that store and forward things to other places where you can subscribe to data feeds. And none of that works if you don't have a healthy open source ecosystem that are building the underlying libraries that bring standardization organically to such a setup. Right, that the open source libraries essentially bring standardization because it's easier to use the library than to roll your own version of it. And so that's what actually our Oata and Trellis framework is it acts as an engine for these sorts of architectures where you have distributed things that the data owner connects up. And it lets them kind of set up their own microservice architecture that actually crosses platform boundaries. And that's the key, that we're crossing boundaries of companies with data going from place to place. And I think that's where you're going to see some of the key sort of cybersecurity issues come up in ag, is that we're not going to house all of our stuff in one, sort of battle-hardened data security center that a large-scale enterprise is going
Hey, Aaron, could you
Yes.
just real quick double click on micro? I think there's a couple of questions. What's a microservice? You might want to explain that just a little bit.
Oh, sure, yeah. So a microservice is essentially any program that's sitting there running all the time that sees data show up and reacts to it, and then sort of processes it, alerts someone, makes a copy of it at another place. That's what kind of the IT industry calls a microservice. The word micro is it's ambiguous as to whether it's micro or just a service, but that's the idea. That like this machinery health service over here in this picture, you could think of this as a microservice from the farmer's perspective. It's a program that's sitting there running, seeing all of his machine data flow in, and then it's determining, from some machine learning models when it thinks a machine is going to break down and it's going to react to it. So that's what a microservice architecture is. In traditional IT, traditional microservice architectures, this picture is within your company. You build one company that does all of those things. Google internally or Netflix internally has microservices that deal with giving you all of your videos, but it doesn't cross boundaries very often. But for a farmer, it needs to cross boundaries. And so that's where that comes from. So if we look at where I think a lot of the digital potential is in the ag and food space, it's that we've got connected machines. Right? We've got $500,000, these things are $500,000. Some of the bigger ones are pushing $1 million now. They drive themselves using satellites in space, but they're also connected to the network. They've got cell connections, and there's drones in this space. There's a lot of kind of in-field data collection, high processing level devices. There's also the lower processing level things that like weather stations, field sensors sensing soil moisture and cloud cover and solar intensity and things like that. There's a lot of opportunity in the livestock space. A lot of IoT in ag is destined for sort of feedback and control, right? My soil moisture sensors determining if the ground is dry should be driving my irrigators' decisions of when to apply water. Logistics tracking of just what's happening now and where, and helping you keep track of those things. And then also there's this huge amount of potential right now in supply chains, because everybody there is pushing for this thing all the way on the right, consumer claims, that they want to provide value added products to the end consumer by being able to tell them something about what happened to it. But along the way, that involves wiring up different enterprises with shipments and tracking inventory and doing data exchange and making sure the food safety certificates and things all along the line. We've done a lot of work in that space, are all properly accounted for. Traceability, when a food safety outbreak, there's listeria on some particular type of produce, trying to figure out where it came from much more quickly than we have in the past. These are all things that are going on right now in the ag and food space. And I think the biggest difference today from about 5 to 10 years ago that affect the data side is this sentence here that the decision makers in food, they think people want to know more about where their food comes from. That's the biggest difference right now, is that's where they're investing their money. That's where they're putting all of their attention, is trying to figure out more about where their food comes from. Even the word sustainable is unsustainable, as we saw from XKCD right here. So this brings up issues of traceability, and what a lot of people mean by traceability is actually transparency, that we should just see everything that happened to all of our food all along the way, which kind of tends to release an awful lot of trade secrets if you just go, full bore in that case. So there's a lot more push for certification of things that happen, regulation, claims. There's a lot of work right now in carbon markets, because ag, of course, it can be a net carbon sink, because we are putting a lot of carbon back into the soil through the roots of the plants that are growing. And so there's a huge amount of effort right now on certifying, did you plant cover crops? How much carbon are you putting back into the soil and things like that, and actually providing monetary incentives for them. So if we look at that world and we say that, what everybody wants from data is automation, there's a dark side to this, that what automation really means is that stuff happens quickly without me. That's what I want. I want a farm and I want the data stuff to take care of itself. And of course, we made the point, it's also across platform boundaries. So stuff happening without me across platform boundaries. And the core direction of food and agriculture is that the people on top think that everyone else wants to know more about where their food comes from. This is your opportunity in cybersecurity, I think, in ag, that there are huge opportunities for privacy, security, and data sovereignty, all of these things as innovative potential in this space. That we need to be able to automate the movement of data so that it doesn't involve the daily interaction of the participants, and yet still adheres to their privacy, security, and sovereignty desires that sort of are table stakes for a lot of these things starting to happen. So I'm going to wrap up here just with a couple things to try to get some creative juices flowing, hopefully. Just some ideas we've been working on within the Oats Center, some of our projects in this space, especially around data sovereignty. And so one of the first ones we had was called Mask and Link. And the idea is that I have data that has to travel across platform boundaries outside of my enterprise. And I want to do the CIA kind of black out parts of the document, right? The thing that I send to you is not the original. I want to be able to prove I have the original, but I don't necessarily need to send you the name and address of all my suppliers, right? And so we call that Mask and Link. So this is actually a library that's up and working. And the idea is we can take a document like this, feed it into a big interconnected network of document processing like this one right here that we've actually deployed commercially at a couple food companies. And data can essentially come in from one side, get parsed automatically, processed, and masked so that the stuff that leaves the company and goes to other platforms to be shared around has actually had all the personally identifiable information removed, or all the stuff that we as an organization have decided we don't want to share, but we're required to have by law. And so how that looks is, instead of getting an original PDF document of, let's say, a food safety certification like this, you would get this masked version where you get all the details that you need, like the score and what product it was. But the addresses and names, they were masked with a hash and a URL to your Trellis cloud. So it means if you have the link and you have permission at my enterprise, you can validate it. You can make sure that I have that data and I didn't change it from when I sent this out, but you don't need to actually see it as you trade this around a complex supply chain. Another example, to go one step further, instead of just proving that I have data, we can prove something about the data that you have. So proving something about data is the process of certification. And the way we do certification today typically looks like this. It's pretty manual, that you would have a third-party auditor, like let's say your taxes. Let's say the regulator on the right is the IRS, and you need to fill out a form for them. It's mandated by law. You have a regulation that you have to certify what you made this year. And so you hire a third party, an accountant, to kind of sit in the middle of your private data, all the actual receipts and things that you did, and fill out the form for you so that you can roughly automate this process, but with a human in the middle. So what does the automated version of this look like? Well, it looks a whole lot like the first one. It's just that instead of a person in the middle, there's trusted software code. And the trick to achieving this is that we've got to make it so that the guy who's receiving the filled out form trusts that you ran the right code. And the guy who has the private data has to trust that the code he's running isn't going to ship all his private data off to the regulator or to CNN or somebody tomorrow. And so this is what private automated certifications from the Oats Center actually achieves. And so if you look at how a lot of the supply chain networks are trying to do things like this now, though, they take a blockchain style approach, especially around traceability. Essentially, they say, well, if you just put all your private data in a public database and we make it immutable so you can never change it, then we can fill out the form and everybody trusts it got filled out right. But of course, that kind of defeats the purpose of a trust transformation here, right? That we want to keep the private data private. And so what you can do when you have an open source framework like Trellis, for example, is you actually have a standard API that tells your code how to access data in lots of different environments. And so that means that you can now write code that you can trust and certify that can be run somewhere, pull data, fill out a form, and everybody knows that it ran correctly. So the trusted software code in the middle we call it an oblivious smart contract. It runs in an enclave called Intel SGX. It can read your private data and produce the filled out form fields that you need from it, and also produce a signature that goes on your private automated certification that proves I ran the right code. I ran the code you thought I ran, and the regulator can then sort of check off on it without having to send a human being out to flip through books and books of paper records for things. So those are just a couple examples, maybe get some creative juices flowing in this space. So that is my talk for today.
Well, Aaron, I didn't say this in my intro, but I'm a computer scientist and electrical engineer by training as well. And so I can tell someone who has not just the deep knowledge of what you're talking about, but you bring a passion to it, and obviously you bring a doing by being at the farm. So I appreciate your, but also as an engineer by training, I'm seeing it because you've elicited a number of questions, but I think you and I always have to remember that we don't always talk to technologists. Mm-hmm. And so you used a couple of terms in there. You talk like microservices. I think we just want to back up a little bit and maybe explain a couple of technical terms that you had in there so everyone's on the same page. So there was one question like around API. What's an API?
That's a good question. I can tell you it stands for Application Programming Interface, but you don't know any more hearing that than you did when you heard API. What it really means from a layman's perspective is it's how one piece of software can get data from another piece of software. Like it's how they can communicate. So I can write data to you, or I can get data back from you. It's the same kind of a thing that happens when you have an app on your phone that like connects to Google and pulls your contacts list or something from Facebook. It's using an API to do that. It's saying, hey, you don't want to have to type in all your contacts to my app, so why don't you just let my code connect to their code and pull it for you?
Appreciate that. And I think the other thing here is, again, I'm going to age myself a little bit. I go all the way back to mainframes and batch processing and the like. And it's always intriguing to me, Aaron, that, the evolution of computing, right? We went from, like I just said, mainframes, which were centralized, then you went to microcomputers, and then you went to, desktops. And now we're going back to this cloud, which in effect is almost back to a mainframe, like where you put everything in one kind of place, And so I think part of kind of explaining how the cloud piece of this works and that great picture that you showed with the cloud, you might want to explain a little bit more on that.
Yeah, sure. So the idea of the cloud was that when we computer scientists would draw our pictures of how things are connected, we'd hit this point that was the internet, right? And so we would just start drawing it as a cloud.
And wait a minute, you're cutting out a little bit
because it was shaded. Actually, going, darn it. Hopefully
Aaron, can you hear me?
I do hear you. Do you hear me?
Yes. Now I can hear you. You were cutting out there.
Yes, you hear me now? Okay.
Yes.
Excellent. I hear rural broadband's a thing. We need we need some work on the rural broadband front. I'm pretty lucky compared to a lot of farmers, but it still needs some work. So the idea behind the cloud was, of course, that when we network people used to draw how things were connected, we'd hit this point where data flowed out to the internet and it was too complicated to draw. So we just drew a magical cloud and said stuff happens in there. And then since you need to kind of invent new terms about every 10 years for stuff, then we started calling it the cloud instead of the internet. But then it migrated to, well, we'll just, it's essentially all of our servers and we'll kind of draw it as one picture. But I think one of the things that's a little different with ag, like I mentioned, as opposed to the tech space, is that it's very heterogeneous. Farmers, the core kind of fundamental level of customer here, are really independent people. They tend to be doers that, the cows have to get milk tonight no matter what. So it doesn't matter if I'm not an expert in that thing that broke, I got to find a way to make it run because it's Sunday night and nobody's going to come help me, right? So we tend to be somewhat independent, and that leads to a much more distributed, fragmented industry. And so so I think it's an exciting space to work in because it's a cool problem to solve. You don't have a Google to come along and just impose standardization on everything. to say everybody must use this or everybody must use Twitter or something. But it also brings its own challenges because the cloud now is substantially more complex than what we'd like it to be.
Absolutely. So let me jump to some of the, because you've listed a number of questions and I still have others for myself, but let me go to our audience. So this is from Kirk. Kirk is asking, are there real world examples of hacking disrupting the food supply chain? That's a great question.
It is a good question. I don't know of any off the top of my head. However, we do work with several enterprise level folks in the supply chain, global companies, and they have just as strong of security concerns. They work just as strictly in the IT space as any tech company I have ever seen, because the problem is if anything goes wrong in their processes, we're talking dead people, right? It gets direct. What they produce goes straight to human beings. And so there are a huge amount of, let's say, attack vectors in this space, and people are working towards it, but I don't know any off the top of my head that, at least that were widely publicized of direct hacking.
Actually, in a related question that came from Greg, and it was related to a conversation from our intro speaker, Senator Hester, asking about any security issues around the water supply chain, and does the water supply chain face similar technology or cyber threats?
That's a good question. Water supply in the rural farming areas like where I'm at tends to be the underground well, right? So the aquifer. And so where most of that comes up kind of in Midwestern agriculture is that the aquifers are running low. And so we need to be, the data in that space is a lot around certifying how much you irrigated and when, and that you had a certificate that said you could irrigate effectively. It's, trading those things to ration the water that is available. I think there are opportunities there to cause trouble. Because in the produce space, especially specialty crops, that water is getting applied directly to food that's going to end up at the supermarket. And so I think there's some more attack vectors there than perhaps in rural, but it is a good question.
So I guess the point is, how do you link all that, right? Because to your point, water is an essential part of what you do as a farm. And so you've got to secure that water supply just as much you have to secure the food supply.
Yes. Yeah. Without water, crops don't grow. Neither do animals.
Let's see here. Again, you've got a lot of questions here. Darren is asking, I think this is about the end of your presentation. How is the accuracy of the private data assured for the regulator?
Oh, that is a really good question. And so the first thing to understand is that in the current way that regulation happens, the accuracy is not assured. In most cases, what the person is certifying is that they have data that says something true, but they're the only source of that information, right? That it's rare that you would have someone else keeping track of things for you. And so the process of automating certifications, the first step in that is just the data that you are legally certifying as I collected this faithfully can be processed automatically. The second step is if it's processed automatically, it's now possible to start applying digital signatures at the point of collection, where you can gain a whole lot more trust in that the data that was being processed had integrity in the first place. But currently, with paper records and things like that, those paper records are the only source. So it's not like automating the analysis of paper records reduces the trust in those records. More than that, it actually, I think, provides the opportunity to improve trust while automating a tedious task.
So you're saying that you still, in your model, the paper would still act as almost a backup for the assurance of the integrity of the digital data? Is that what you're supposing?
It can, yeah. Generally, farmers don't like to enter stuff twice. And so if they have a means to sort of certify that this was done correctly, if it becomes digital, I've seen it in several different cases where that is what pushes them towards digitization. That instead of collecting things by hand, writing things on paper, it pushes them to actually just make the original point of entry be digital in that case.
This isn't a question for audience, but it's just one that just from your answer. Is there and not trying to be disrespectful to anybody, but is there a generational challenge with this, older farmers being able to accept this versus, obviously, I don't know your age, but you obviously look a little bit younger. And so you have a different educational background than probably the traditional farmer as well. So do you have a generational challenge in getting these digital technologies accepted into this space?
Now, strangely, farmers actually, the older ones are better with technology. No, I'm
Okay.
kidding. I'm kidding. I'm kidding.
Okay. I was gonna say, good to hear.
Yeah, it's the same as the general population as a whole. That the average age of the farmer, I think, is pushing mid-50s right now, and so that is a gap. But what I've seen with the farmers that I know, so I haven't done an extensive study in this, is that the advent of the smartphone that made this box that you can push a button that does things. Once someone brings that to the farm, it's a skill that they're happy to learn as long as it simplifies something they had to do otherwise, right? So if they were writing this stuff down, I'll give you an example. The cows on my farm, we need to have a record of every antibiotic shot that we give them. That's required by law. So if he's sick and I'm trying to figure out what to give him, I give him penicillin. I have to write down that calf got penicillin. And that actually takes a while. If you have thousands of head and you have an outbreak, you could give 50 shots a day, and that could take 3 or 4 man hours of just writing down stuff of what he had today, and it's really tedious. And so I wrote an app to automate that, right? So that the calf's in the chute, you can just say he's got this, hit the button, and there was zero issue with uptake on that because it sped up the process. What was interesting was in speeding up the process, it's also enabled us to learn more about what, like, for example, on paper, when I'm writing down what the calf has had, I don't know what he's had previously. Maybe he was in 3 days ago and had penicillin already. I shouldn't give him penicillin again. If it didn't work, I should use a different drug. But with the app, it can tell me that while I'm typing in his record. It can say, oh, by the way, this calf had penicillin 3 days ago, so you should try something else. And so not only do we do a better job treating calves because of that, we reduce the amount of effort. And this is the key. The data quality is immaculate. Because I learned what I wanted in the moment. And so I know if I don't do it right, tomorrow, if that calf's back in, I'll get a wrong answer. So everyone on my farm that gives shots does a fantastic job of actually taking that data, because we're all sort of tricked into taking it. We want to know what the calf had, so we'll go to the trouble of entering him to learn what it had.
And so that's the logic you're using to get farmers to kind of accept that there is this, they can just be better farmers at the end of the day, and they can have a high level of productivity by having this data and having this information.
Yes, and I will say, if you're breaking into this space, farmers are used to a whole lot of technology for technology's sake. We made it because we could, and it was cool, but it didn't actually solve a problem. It solved a problem maybe someday when we have a bunch of data collected, but it didn't solve one on the ground.
Well, that actually leads to a question from Marjorie, a little bit long, but I'll read it. Our experience as a precision ag company is that farmers will spend hundreds of thousands of dollars on a tractor and equipment, but they do not want to spend money on technology separate from that. This strikes us as a challenge for cybersecurity. Your thoughts?
Yeah, that is a very, very good question. And so first, that doesn't mean there is no viable business model. One business model that a lot of companies have taken is they just roll that into the price of the tractor, right? You add your $100 software fee into the $500,000 tractor price, and I don't even notice it. And so there's options to roll that in. There's also options to roll that into the input side of things, right? So partnerships with seed companies and partnerships with crop protection, which, the fungicides and things we would spray on crops and stuff like that. A lot of current businesses will roll those into that model as well. But I'll also say that if you look at the population as a whole, very few of us like to pay for technology, right? We'll buy hardware, we buy computers, but we expect Facebook to be free. We expect Google to be free. We expect Twitter to be free. And yet somehow those companies make tremendous amounts of money. And so I think there are some very useful ways to apply knowledge from other spaces in business models in the ag space to get around this issue that, if you show up at a farm and ask them to, buy your software, that you got to really make the case for them. But on the other hand, I have seen things work where if you're not just bringing them technology that you think that, that's neat, if you're bringing them something that really solves a problem, one nice thing about farmers is that their price point isn't a $5 app necessarily. If this is something that's significant, that can actually improve the farm, improve my logistics, improve the operation, you know, they will spend thousands of dollars, not fives of dollars on these things. And so that also can simplify, especially kind of the early hurdle of the early adopters getting in, that you don't have, you know, $55 people, you can have 50, 500 or $1,000 people, and it's a big difference.
So it sounds like part of what you're, tell me if I'm making assumptions, that, you know, like you said, there's no Google or Facebook that's dominating the space, but there's clearly a need for somebody to bring some platform like a model that can be adopted across this ag space that really would be that kind of standard that everyone would plug into.
Well, there are a lot of platforms. And that's the thing, that the business model was, well, we'll just make the one platform to end them all. And I think a lot of people have struggled with that space. So I think the real key is working with existing platforms, and the way to break in, especially in the startup side of things, is not embarking on a business model where you have to buy all of our stuff or none of it works. Like, you can buy some of our stuff, you can try a little of our stuff for free, and then it'll work with this other piece that you have. In other words, it's building up things incrementally instead of requiring a complete shift. I don't have to change my accounting software to you and all of my tractor, you know, like, these things can work together. So.
Well, that actually leads to a question from Catherine, where she's asking, as a dev shop that focuses on customization to support this ag interoperability, I have seen many ways that this data does not match smoothly between systems, which can cause complexity. How does Trellis handle the differences between the data types in the siloed or legacy systems?
That is a good question. And so one funny misconception in the ag space that I found, especially when we first started in the data space, is that the ag industry, what they think the word interoperability means and what farmers think it means are not the same. And so it's kind of like the movie The Princess Bride, when he kept saying inconceivable, and I don't think that word means what you think it means. It's that way here, that the industry, what they mean is we all use the same file format, right? Like we all picked the same data model. And of course, what the farmers think it means is I don't have to mess with stuff. And so there's a whole lot more to me not messing with stuff than just the data model. The data model is part of it. But the problem with the data model, so like the ag industry focuses all its efforts then, or has, on trying to find, like they treat the data model like there's one right one and we just need to discover it. And if we all get together and meet, we can all come up with the one right data model to end all data models, and then, you know, interoperability will be solved. And unfortunately, if you've worked, especially if you've worked, as Catherine mentioned, you know, in integration much, there isn't one right data model. How you model the data is directly tied to what you're trying to do with it, right? Like, if I'm trying to show you a map on your phone of all of your fields and you want to navigate, I need to be able to query that data, like, by the viewport on your phone. I don't need the phone to download 5 gigabytes of all your past yield history and then I can process it and figure out your fields. I need it to just get the one in that spot. And so that means that you're inevitably going to have, in the domain-driven design community, they call it bounded contexts. You're going to have areas where we have to call something one thing, and when we shift across a boundary, we've got to call it a different thing. It's just the way it is. It's got to be modeled differently, and so you have to have translations. And, you know, the way that the tech industry tends to solve that, let's look at images, for example. There isn't one right image format. Right? There's JPEGs, there's PNGs, there's GIFs. All of them are standards, right? It's not like the absence of a standard was the problem. The problem was each one solved a different problem, right? Like PNGs solve a different problem than JPEGs and GIFs and so on. The solution was the translation code is open source. That's the solution. That's how you eliminate these headaches, is when you push the translation between data models into open source libraries, you push the onus of maintenance of the code onto the source, so that the people providing the data are the ones that have the incentive to keep their stuff up to date and make it work with other things. And they have a vehicle to do it, versus all the destinations having to continuously replicate the integration code in all of their platforms. And so that's one of the things with Trellis that we tried to bring. We tried to say that there is no right format. There are just lots of existing formats that need to be represented, published and identified. So when your system connects to another system and the farmer's not supposed to have to mess with it, it can identify what format it's got, feed it to a library that knows how to read that format that's also published open source, and convert it to whatever thing you want.
So it's a big
So I
translator.
think the
It's a
creation of
translator.
that open source community is
Mhm.
the answer. That's the way you solve that problem.
So it acts as a translator, basically. It translates between what it needs to see and what it needs to be put into. That's
Yes.
a translator. Or catwalk, in our term, we call it a catwalk. It acts as a big, an AI-driven catwalk-like table, it sounds like to me.
Yep. Open source translators. That's
Yeah,
it.
exactly. So Darren is asking, is Oats collaborating with Purdue Extension and or other extension programs? And if so, in what areas?
That is a good question. So there are folks within Oats who are some of our professor members. So Oats itself is an industry-led center. So you join Oats actually as a company, and then you can be involved in a lot of the open source work that we do, meet other companies that are also working in this space. It's some great networking opportunities. In addition to, we have students actually work on open source tech that our members value in that way. It creates a lot of opportunities. But we also do work with Purdue Extension because, as I mentioned, some of the professors in the center are Extension. And so we've got some work right now in the produce space with Extension, creating some apps, or actually we're brainstorming some apps right now to help simplify and digitize a lot of the food safety recording practices. We also have some open source apps under that banner, the Open Ag Toolkit, that our extension folks can take out and show farmers how to use and things like that. So yes, we do work with them some, but a lot of our work is the actual development, and they're sort of the sales channel in that so to speak.
So Andrew is kind of half joking, but he brings up a question as well about some of the challenge you've had with your connection today. He's saying you need to fire up that Starlink connection.
Yeah.
But one of the questions I had, and you mentioned it a couple of times, is what is the kind of connectivity issues when you're in the field? You're out in the field. You mentioned cellular, but is it Wi-Fi, cellular? How do you actually get those connectivity on a 3,000 acre farm?
So I am blessed to have LTE pretty much across everywhere I farm. And so I've got cellular everywhere. In my farm, I've just used long range Wi-Fi access points. And so I've got about 10 square miles of blanketed mesh coverage where I'm just on Wi-Fi everything here. But I also have LTE as a backup anywhere I need to go. So that's handy. But the reality is most places, especially as you move west, and I remember even talking with Mike when we were in Maryland last time, that this was a significant issue in Maryland, even though it's a little bit more densely populated, that the reality is when you build apps to work in the field in ag, they have to be offline first, period. Like you have to build apps that can function when there is no connection, and when the connection comes back, it can sync behind the scenes. We actually built that as one of our top level design considerations within our Trellis frameworks as well, that if you're going to build things that do that, you need tool sets that actually simplify that process. So,
got it. So Andrew's also asking, when he brought up the Starlink connection, he's also asking two questions, if I may double question it. He's asking, what is a hash? And I probably should have something I should ask at the beginning about clarity on terms, but he's also asking, what is the near future of the cloud and local and rural data centers?
Those are two completely separate questions.
Yes, exactly.
So a hash is the simple explanation of it is I have a piece of data and it's really big, and I want to have something that if you give me something small, I'll know if you changed your big data by just keeping the small thing around. And so an easy way to do that, you can imagine if you wanted to make one of these yourself, that small thing's called a hash. If you want to make one yourself, you could just take your original data, like your Word document, for example, and just take all the letters in it and line them up in columns, like 10 rows, 10 columns wide, line them up, bunch of rows, and every single letter, you assign a number for it. So like all the T's are 71 and all the G's are 84. You just assign a number. And so you'll end up with a bunch of columns of numbers. If you just add up all the numbers at the end, you'll get a new number. And if I'd have changed any of the letters along the way, the number at the bottom would have been different. And so that's an example of how you could make your own hash. It's not a very secure one, but the idea is if I change the big message, the little thing changes. And so if you create a hash of your original data and send that to someone, then I can recompute the hash later on the original data and know if you changed it, because the thing that, like, the sum is going to be different at the end. So that's what hash is. Then the future of the cloud in rural, I do think because of some of the connectivity issues and just the bandwidth available, edge computing is a significantly bigger deal in agriculture, especially given that agriculture fundamentally tends to cover large geographic areas, which, you know, is the opposite of what works well with cellular and you know, typical high throughput pipes. And so I think you're going to have a lot of opportunity in the edge space, where you're going to be doing a lot of the, you know, AI machine learning things at the edge. And I think if you look at some of the you know, kind of really early players in this space, like FarmBeats from Microsoft, for example, that's where they focused as well, I think. So
gotcha. Ewing is asking a pretty interesting question. At least for me, I think it's interesting. How do farmers get paid for their information that are used for these networks?
that's a good question. Very few farmers do get paid for their information. It's different depending on the industry that you're in. Like in the produce industry, your data is your food safety certifications. In the livestock industry, your data is like your livestock handling certifications and things like that. That's what typically gets exchanged. And those are just table stakes. You get paid by having access to the market. You can't sell your stuff if you don't have the certificate. And so it's just kind of built into cost of doing business there. There have been some companies that have tried to pay farmers for their data. Grower Information Services Cooperative, GISC, was an example. Farm Mobile is an example where they actually produce a telematics unit that sits in a tractor, which is essentially it watches what the tractor's doing and sends stuff to the cloud. And they package all that up and make it resellable for people. And then they'll pay some back to the farmer if people buy the data from their farm. So there's a lot of
Aaron, would you lose you?
different options, I think. But
Aaron, you're breaking up a little bit, buddy. No, one last question, if you don't mind. Are there any government regulations around data certification or standards?
That is a good question. So there's a significant amount of regulation in the Food Safety Modernization Act in those areas. There's actually active work right now around a part of that called FSMA 204 that is currently targeted at the produce space, but it's the non-produce spaces are all kind of worried that it's going to eventually bleed over into other areas of ag as well. And so there's active work there on the regulatory side. In livestock and especially with environmental requirements, there's a significant amount of data requirements in that area, because livestock produce manure gets spread on ground, and it, you know, then nitrates and phosphates can build up for runoff and things like that. And so, yeah, there's huge amounts of sort of record keeping requirements. The privacy side of things, there hasn't been as much. There was a big push by the American Farm Bureau back in about 2015, I think, that a lot of ag companies kind of signed on to this ag data, sort of what was the right way to do ag data privacy agreements. And from that effort spawned a thing called the Ag Data Transparency Evaluator, which is headed up by a legal firm actually here in Indiana, that they'll analyze your user agreement and kind of give you the green check mark of goodness or not. But there's not a significant amount of direct regulation in that area. And there also hasn't been a significant number of court cases or anything that have tested it. So it's a little bit of the Wild West at the moment.
Gotcha. Well, Aaron, I have enjoyed it. I've learned a lot. It sounds like our guests have as well. We really appreciate your time today, but more importantly, commitment to helping this whole CyberAg get stood up. I think I got one more message. Let's see what's this. So again, I want to thank everybody. Mike, I think I'm going to be turning it back over to you.
Well, listen, thank you so much, Troy. Really good facilitation. And Aaron, you know, you're golden. We really appreciate you bringing your perspective to Maryland. Again, just as a recap, it's been twice that we've brought you to Maryland. You were the keynote speaker at our very first symposium. I think it was in late 2017, and you sort of rocked the house when you gave a presentation, and that's the reason we brought you back last year. I think it was last December. And we did a 3-day world tour through Maryland to include a testimony in front of the General Assembly, Senator Hester's Joint Committee, and then I ran you to Southern Maryland, Central Maryland, and then up and down the Eastern Shore. So what we've been trying to do is advance what you're doing with Oats and trying to get open source data on everybody's brain here in Maryland, and now with adding the cybersecurity component, hopefully we've stimulated some thoughts, and we've maybe encouraged some of our companies and entrepreneurs and innovators to come engaged. Christina, we've got 5 minutes. I'm going to let you field any last minute questions maybe with Aaron while I get our other speakers kind of set up.
There's one more. There was one last question. I missed it.
That'd be great.
Yeah. One last question from Catherine. Catherine again. I have seen, it's a little bit long, so bear with me. I have seen reticence from private ag companies and sometimes growers to share the farm data of their users. But I think there are many places where that data could help drive sustainability and better metrics for all farmers to increase yield and identify best practices. What do you see as a way to get the second while respecting the first?
So Catherine asked great questions. So I think to understand the reticence of sharing data, you've got to understand a little bit how the cloud came into the farm conversation. And so the way that essentially for about 15 to 20 years, data was the future. It's still the future in agriculture. And so farmers bought into it a lot. They heard it over and over and over and over again, but nothing was connected. Nothing worked together. And so data that doesn't work together is not terribly useful. And so then the cloud conversation came onto the scene where essentially I'm not getting all that much value out of my data, but those guys might steal it from me, right? Like now they may have access to it. And that unfortunately drove a lot of the reticence right now, that the question of how do you feel about sharing your data has to be counterposed with to do what? And so nobody likes sharing their data for no good reason.
Yep.
It's more a question of, would you be willing to share that to make that app work or something like that? So I think the solving that problem is finding the real value to the farmer that is why they would share the data. And that's the conversation.
That's the conversation. I agree with that. No, that makes sense. Well, again, Mike, Aaron, thank you. This has been great. Again, I've learned a lot. It sounds like our guests have learned a lot. So I appreciate them, appreciate their questions. And Mike, good luck for the rest of the conference.
All right, great. Thank you both. Appreciate it very much.